Hello everyone, welcome back. So today we'll be talking about the difference between an aldehyde and a ketone. Stay tuned. As you know, an aldehyde and a ketone are one of the many functional groups that a molecule can have. They are very similar except they differ in one aspect, and that is a hydrogen bond. I'll explain it to you. So let's first draw an aldehyde. You have a carboxyl group, which is the oxygen, double bond to a carbon, and then you have the R group, and then you have that hydrogen. This is a special hydrogen that sets them apart. With a ketone, you have the carboxyl group, which again is the oxygen double bond to a carbon, and then you have two R groups. So therefore you don't have a hydrogen. Simple as that. That is different between a ketone and an aldehyde. So let's do some examples. Okay, out of these two molecules, which one is a ketone and which one is aldehyde? First, we look for the presence of that hydrogen element. Again, we see it right here. We know hydrogen always goes with aldehyde when it's connected to a carboxyl group. So therefore, we can say this is aldehyde, and this is a ketone. Okay, let's move on to the next example. So here we have two different molecules. So let's first look at the top one. We say that we have our carboxyl group, which is our oxygen double bonded to a carbon, and then we have the R groups, two R groups. So you have two R groups instead of an R group and a hydrogen. Therefore, we know this is a ketone. Even though the hydrogen's over here, it is not connected to the carboxyl, or the carbon on the carboxyl directly. Okay? So let's look at this example. We have our carboxyl group, we have our carbon, and again, we have two different R groups, all right? We don't have a hydrogen here or a hydrogen there, we have two different R groups, so therefore this would be a ketone. Okay, let's look at this first example. This one, we have our carboxyl group, again, the carbon, double bond to the oxygen, and then we have one R group, and then we have a hydrogen bond. All right, so therefore we can say that this is aldehyde. Why? Because of this special hydrogen bond that's connected to the carboxyl group. So we know this is aldehyde. So now let's move on to this example. We have our carboxyl group, which again, our oxygen double bond to our carbon, and then this is connected to a hydrogen and an R group. So therefore, this is also an aldehyde. So let's review. Aldehyde and ketones are two of the many functional groups that a molecule can possess. Aldehydes and ketones look very similar. They only differ in one aspect. They both have a oxygen double bond to a carbon, and then for an aldehyde, it only has one R group that is bonded to, opposed to a ketone, it has two different R groups that is bonded to. An aldehyde only has one R group bounded to because it has a hydrogen that the carboxyl is attached to. That is the main difference that separates aldehyde and a ketone, the presence of this hydrogen atom. As we see in this example, we have our carboxyl group, oxygen bounded to our carbon, double bonded, and then it's connected to two different R groups. So therefore, this makes it a ketone. You don't see the presence of that hydrogen in one of the R groups. And again, this makes this aldehyde because you have your carboxyl group, and then the carbon of that carboxyl group is bounded to an H, which is a hydrogen, and then it's bound to an R group. So therefore, it's aldehyde. Thank you all for watching. Stay tuned for more.